Okay, this is our last lesson on end behavior and multiplicities. We will be putting together what we previously learned in this lesson regarding our leading term to determine our end behavior and finding the zeros to talk about what's happening at the x-intercepts, okay? So our goal is, given a polynomial function and its graph, we are going to determine the factored form of the polynomial function. Okay, so remember that zeros are associated with the factors of polynomials. So if we have f of x is equal to x plus 2 times x minus 1 times x plus 3, if we were to find the zeros by setting this equal to 0, we would have x plus 2 equals 0 to give us x is negative 2. We'd have x minus 1 is 0, which gives us x is 1. And we'd have x plus 3 is equal to 0, which gives us x is negative 3. Okay, so if you're given the zeros, you can work backwards to find the factors. Okay, and so what that looks like then is, if you were to say, okay, my 0 is x is 2, if you were to add 2 to both sides, you would get x plus 2 is equal to 0, which is the exact factor it came from. Okay, and we're going to practice this a little bit more later on. Remember also, our occurrences of zeros are the multiplicity of each. So we have, if we set this equal to 0, okay, we'd have x is equal to 0 with a multiplicity of 6. We would have x minus 2 equals 0, which gives us a 0 of 2, and that has a multiplicity of 2. And then we have x minus 3 is equal to 0, x is 3, and that would have a multiplicity of 4. That's how often they occur. It's also the exponent of the factor that it came from. Okay, so if we put this together then, if we're given the zeros, we can determine the factors of the polynomial. So our zeros are negative 1, 2, and 3. Okay, so this is like saying x is negative 1, x is 2, and x is 3. Now remember, when we find the zeros, we take our factors and we set them equal to 0. So we can solve each of these little equations, get the side equal to 0, and we'll have our factor. Okay, so we could add 1 to both sides, so we would get x plus 1 equals 0. And I'm putting it in parentheses, that's going to be one of our factors. Same thing. Okay, so we have x minus 2 is equal to 0. Subtract 3, we have x minus 3 is equal to 0. So in factored form, this looks like x plus 1 times x minus 2 times x minus 3. And if you were to set this equal to 0, you should get the zeros that were given, negative 1, 2, and 3. Okay. Example 2, given the zeros, determine the factors of the polynomial. So now we have zeros with different multiplicities. Okay, so first I would say determine the factors that each of these zeros came from, and then we'll add in the multiplicity. Okay, so we have x equals 0 from this first one. We have x equals 2, and we have x equals 3. And we'll do the same thing to determine the factors. We can make sure that one side is equal to 0. You may also know the pattern by now too, and you could jump straight into, okay, this is x minus 2 equals 0. Okay, or you can solve each one. Okay, so what we have now in factored form is x times x minus 2 times x minus 3. But we're not done yet. We have to make sure we incorporate the multiplicity. So 0 has a multiplicity of 2, which means that our power of x, okay, remember from x we get the 0 of 0, and it has a multiplicity of 2. So that means the exponent of that factor has to be 2. Okay, 2 has a multiplicity of 1. You don't have to write it there, but there could be a 1 there. And 3 has a multiplicity of 4, which means our factor that gives us the 0 of 3 has an exponent of 4. Okay, so this is what it would look like. I don't know if MyLab is going to want you to put the 1 there, so I'll just erase that. Okay. So remember also that we can connect multiplicity to the x-intercepts in the graph. So if it has an even multiplicity, the graph touches the x-axis. Okay, and if it has an odd multiplicity, if our 0 has an odd multiplicity, then the graph crosses the x-axis. So what we can do is we can put this all together. So what you're going to be given is a graph of a polynomial function. From the graph, you'll be able to identify the zeros, and you'll be able to see whether the graph crosses the x-axis or is tangent to the x-axis. Okay, and that tells us whether the multiplicity is even or odd. And then you'll be able to look at the end behavior, how it ends up when x is very big or very small. It can do different things, okay? And then that could tell us if our leading coefficient is positive or negative. So let's do a few examples. These are matching problems, and so the first slide we'll just talk about the zeros and what's happening for the graph, and then we'll match on the second slide. Okay, so the graph of f of x is given below. Use the graph to factor f of x. Okay, so f of x should be a bunch of factors. So we're given x cubed plus 5x squared plus 3x minus 9. Here's the graph. So let's identify the zeros. So our first zero is here at -3, 0. Okay, and our second zero is here at 1, 0. Okay, now remember, or those are our intercepts. Okay, now remember, these numbers here are the x-coordinate of the intercepts, or our zeros. At -3, 0, it touches, which means that this needs to have an even multiplicity. Okay, at 1, 0, it crosses. So the multiplicity there should be odd. Okay, so let's take a look at our zeros and possibly the factors that they came from. So my first zero is x is -3. If we add 3 to both sides, we should have a factor of x plus 3 with some even power, okay, because since it touches, it tells us that our multiplicity is even, which means that the exponent is even. Okay. We also have x is equal to 1. If we subtract 1 from both sides, we have x minus 1 as our factor, and then it should be to an odd exponent because it crosses. Okay, so then we can match it up. So, also our end behavior, okay, our leading coefficient should be positive. Okay, so if we put it all together, our leading coefficient positive, so that knocks out that one. This is not correct because this gives zeros of 3 and -1. This looks like it's okay, but double check. This would give us zeros of 0, -3, and 1. 0 wasn't one of our zeros, so the correct answer here is B. Okay. Example 2, the graph of f of x is given below, so we're going to do the same thing. First, let's take a look at our x-intercepts. We have one here at -3, 0. We have -1, 0. We have 1, 0. And we have 2, 0. Okay. So now all of them cross the x-axis, so all of the multiplicity should be odd. And then our end behavior, we've got a graph that's smiling, so our leading term should be positive. Okay, so if we take a look, we have a 0 at x is -3, which corresponds to the factor of x plus 3. Okay, and it should be to an odd power. Even 1 would count. We have x is -1, so this gives us x plus 1. That's also to an odd exponent. Okay, we have x is 1, which gives us x minus 1, odd power, and then we have x is 2, x minus 2, also an odd power. Okay, so it's helpful to write this out. I wish I could fit all of the multiple choice answers on this slide, but I can't. So on this slide, we just kind of talk about end behavior, what's happening with the zeros, and then we'll match it on the next slide. So make sure you have this written down. Okay, and what we're looking for, so this first one, so what I like to do with multiple choice is I like to eliminate the ones that are wrong. So this is wrong because this would give us a negative, I shouldn't have crossed it out so fast. This negative in here would give us a leading coefficient that's negative, which would give us an end behavior of the frown, okay, which doesn't work. D has 5 zeros, 1, 2, 3, 4, 5, and we only came up with 4. So now we're looking at A and B. If we match it to what we wrote, the correct answer is A. Okay. Have one more example. The graph of f of x is given below. Use it to factor f of x. And so here, looking at our zeros, we have a 0 at -3, 0. We have a 0 at 0, and we have a 0 at 2, 0. Okay. It crosses at -3, 0. It crosses also at 0, 0, but it touches at 2, 0. Our end behavior, both sides are going down, so this tells us that we're going to have an even degree that's going to have a negative leading coefficient. Okay, so one of our zeros is x is -3, and so this becomes a factor of x plus 3, and it's going to be to an odd power. We have x is equal to 0, which just gives us a factor of x, and that's also going to be to an odd power. Okay, and that's coming from this one. And then we have x is equal to 2, which gives us x minus 2, and this should be even. Okay, so if we match this up, we do have to have a negative leading coefficient, so B, C, and D would give that to us. And now we have to match up our factors. So we did have a factor of x. We had a factor of x plus 3, so D is out, and x plus 3 should be to an odd exponent because the graph crosses there. Okay, so we're looking at this one, and that also matches x minus 2 to an even exponent. Okay, thank you for watching. If you have any questions, feel free to reach out to me.